So in last lecture, we were looking at this defect removal efficiency. So the defect removal efficiency basically deals with EMD, which is nothing but the number of errors which we have found before the delivery and number of defects that we could get from the customer's side. So on the basis of that, we can have this defect removal efficiency. And also we have to make sure that the errors which we found in any particular activity of our software engineering process development, we should not let it go further onto the next activity, onto the next framework task. Okay, and that thing we can handle or will deal with that particular thing to track of that. We can have defect removal efficiency DREI is equals to EI divided by EI plus EI plus 1. Okay, the whatever we have found in activity I and whatever if we manage those errors to not let them go further in activity I plus 1. So that's all about that. So that's this defect removal efficiency DRE is one kind of measure of the efficacy of you can say our early SQA activities. That is nothing but the uh, software software quality assurance activities. If DRE is Yeah. So if DRE is low during the analysis or the design phase, then we should spend some time so that we can improve the way. We can improve our. Excuse me. So we have to spend some time so that we can improve the way our improve the way to conduct that formal technical reviews and all those activities. Okay. Now coming to the next topic, that is the metrics for small organization. So there are some kind of metrics which we can use when dealing with this small organization, and that is the TQ, which is indicating the time elapsed from the time a request is made until the evaluation is complete. So we can keep track of that time. Then effort to perform the evaluation, then time elapsed from completion of evaluation of assignment of change order to personal, then effort required to make the change. So basically all these things are dealing with effort and time. And on the basis of that, again, we'll have this DRE, defect removal efficiency, is equals to E change divided by E change plus D change. Okay, where D change is nothing but the effects uncovered after change is released to the customer base. So after that, we are having some number of steps that we should follow to establish to that we can follow to establish any metrics. Okay, so we can first start with identifying our business goals. Then we should go for the identifying uh, what what we exactly want for that particular product or software which we are going to be developed. We have to identify the sub goals, identify the entities, attributes related to that sub goals. We have to formalize the measurement goals. We have to identify the quantifiable questions and the related indicators that will use to help to basically achieve the whatever the goals we have set. Okay, then the next we can do is identify the data elements that will collect to construct our to basically solve the problems or to solve the questions. Okay, goals and sub-goals related questions. We have to define the measures which we can use. Then we have to identify the sort of actions that we can take, that we have to take to implement those measures. And basically, we can prepare a plan for implementing all those measures. So there are a number of some steps that we should follow while establishing one matrix. So that's all about this metric software project metrics. Now we'll see the next thing. Number 9. So the next diagram that we are going to look is the data flow diagram. So basically, data flow diagram is used for information system because information system helps us in managing, updating the vast business related information. And before designing such information system, it is helpful for us to identify what are the various stakeholders and the information that they would be exchanging with that particular system, whatever the system we are going to deal with. So this information system is itself a large software which comprising of a number of modules, and it shares the some kind of process uh, in between those modules to share the data, whatever the data available with that particular system or flowing in that particular system from one module to another module. Okay. So these data are often, you can say, stored in one database, a number of databases for that particular system. So a data flow diagram is used to graphically represent whatever the functionalities provided by that particular information system by focusing on the sources and destination of that data, where the data is coming from and uh, where it is now going after some kind of processing in that particular system. Okay, so DFD is the graphical representation of the flow of data from one component to another component in any information system. DFD basically provides you the functional overview of your system. Okay, this graphical representation easily overcomes the gap between the user and system analyst. Okay, so that, and you can say it decreases the gap between the user and system analyst and system designer, because we have represented the whole system graphically to understand the system. Starting from the overview of the system, it explores detailed design of your system through a certain hierarchy. So DFD basically shows the external entities from which data flows into your system, into certain process of your system, certain functionality of your system, and also it shows some other kind of flows of data within your system. Okay, we can basically give the overview of the system without going into the deep detail of the system, without going into the like the technical part of the system. Okay, it just includes the transformation of data flow by the process and the data stores, that is our database, to read, write, or to deal with the data. So basically, there are four main symbols used in data flow diagram. The first is the external entity. The whatever the external entity is there, it is represented by this rectangle and the name is written inside that. And another one is the process. Process is basically represented inside this circle. The name written within that circle. The next is the data store. Left, right, open rectangle is used to represent the data store, and again the name is written inside that shape. And the next one is the data flow. That is nothing but where your data is flowing from one component to another component. It is represented via this directed arc with the data name, whatever the operation you can say is going you want to represent. So what is this? Each of this symbol is representing. Starting with the process. So this process is any function which is being performed, and as I told you that they are represented using this circle, and the name of that process is written inside the circle. Okay, so the name of the process, whatever we are using, it is usually given in such a way that that it will represent the functionality you want to show or the system is performing. Okay, whatever the functionality your system is performing and that you want to represent through this pictorial thing. So the name of the process should be in such a way that it justify that particular functionality. Say for example, in ATM system, like uh, the process can be verify password or PIN transaction, PIN verification, sorry. Okay, so those kind of things we can represent using as process and inside the circle. The next one is the data flow. So the data flow shows the direction of data element movement. The data flows are nothing but one kind of directed edge between two components of your data flow diagram. Okay, so the it is nothing but data. It is represented that data can flow from external entity to the process. Okay, or we'll first understand what is this external entity. External entity is a source or destination of data element, and uh, whatever the data is there, so this external entity send that data to be processed, and again they can receive that processed data. Okay, so it is one kind of source or destination of a data, and they're basically representing that who are responsible for the processes. Okay, whatever the functionalities that we are doing in our system, so this external entity will represent that who are responsible for those processes in our system. Like you can say external entity can be admin or customer or doctors, like in such particular scenario. Okay, then patients. Also basically, to derive a process, we require this external entity. They can send data to be processed, and they can also receive such data, whatever the process data is there any uh, from any process. Okay, so they can receive also. So that is something, but we talk about that earlier, that data flow, so that data can flow from this external entity to process, and it can also flow from that data store, that is nothing but a database, to process, and in between you can say processes or vice versa. Okay, basically it is the data flow arrow is representing that how your data is flowing from one part to the one place to the another, and that data store is nothing but the, it is one kind of location where your data are stored. Okay, and so that data store is nothing but one kind of location where you store your data for your system, and they are represented by left, right, open rectangle, and whatever the name of that data store is written in between that two horizontal lines of the open rectangle. So data stores are just one kind of repositories from which data can be flown in or flown out, or you can say from a process. Okay, so data store is nothing but one kind of database in every system, like hospital database, bank database, doctors database, patients database, etc. So these are the four main important symbols: process, data flow, data store, and external entity. Now the next is the DFD labels. Okay, so there are many labels: level 0, level 1, level 2. So first of all, how this all DFD thing is going on. So first, we start with a broad overview of our system, and that we can represent in level 0 diagram, which is also known as that context diagram of our system. So in that case, the entire system is shown as a single process. Okay, like this entire process is shown as a single process, and also the interactions between the external entities with that particular system is represented in this context diagram. Okay, and further as we go, we can split whatever the process we have represent in this level 0 diagram. We can split that process in next levels into several number of processes to represent the detailed functionality. Okay, detailed functionality which is going to be performed in that system. So and also you can say that the data store can appear in higher level of DFS, right? So basically level 0 is giving you the overview of your system. And there are some certain rules of DFT, that process must have at least one input and output. A data store must have at least one data flow in and one data flow out. Data store must go through a process, and processes in a data flow diagram go to another process or a data store. Okay, but we have to remember that no data store should be there at level 0, right? And there should not be any direct data flow between two entities and two direct data stores. Okay, direct data flows, we can have direct data flows between two processes. So as I told you that this context diagram, that is the level 0 diagram, is giving the overview of our system, and it is the most abstract data flow representation of our system. Okay, it represents the entire system as a single process, and this process is labeled according to the main function, you can say, of your system. And there are some various external entities with which your system is interacting. Okay, and whatever the data flow occurring between those system and those external entities are going to be represented in this particular level 0 diagram, right? We can show that data flow in this diagram, and the data input to that system, data output from the system are also, we can represent as incoming, outgoing arrows, like you can see in this general diagram. So this data flow arrows should be represented with the corresponding data names. Okay, as I told you that whatever the process name that you have to give, that should justify the functionality. Same way the data flow arrows, whatever the name you have to give that to that particular data flow arrows, that should be represented in a such way that it represents whatever the uh, it should justify that your data is moving from, it should justify the reason that your data is moving from this part to the another module. Okay, so this main context diagram is well justified because it represents the context in which your system is exist. Okay, and all those external entities who would interact with that system, and the specific data items that we would supply to that system, and all those data items with which uh, the data items that would receive from the external entity, or you can say they are passed on to that particular entity, in and out arrows are there from this system. So all those things we can represent using this context diagram, that is the level 0 data flow diagram. One more thing is that this to develop this data flow diagram, it is a good practice to analyze the software requirement specification document. Actually, for all the diagrams we are going to, obviously, we have to identify that, we have to analyze that software requirement specification document to identify the different types of users who would be using that system, and the kinds of data they would be inputting to the system, and the data they would be receiving from the system. Okay, so whatever the users of the system that we could identify from that SRS document includes the external entities, okay, external system which supply the data to, or to the system, or receive the data from the system. So so that we can generalize the idea from this level 0 DFD diagram. This process in this context diagram is represented with such name of your software system. Okay, whatever the system that you are going to, whatever the system that is there for which you are going to develop this particular data flow diagram. So whatever the name is there, that is going to be written inside that circle. Okay, and you can say that that is in contrast with the process which we have in the further levels, in the deep, you can say detail levels, whatever we have to represent the detailed functionality of our system. So you can say that is the more detailed version of all those processes as a more detailed version of that process which we are indicating in this particular level 0 diagram. Okay, and this whole level 0 diagram is basically giving the context of the system, rather than it is not focusing on the functionality. Okay, whatever the functionality that our system is going to perform, that will going to represent using the higher level DFT, that is level 1, level 2. But here just we are going to give the general overview of the system, the context of your system, that uh, abstract version of your system, right? Are you getting this? Have you studied DFD earlier? Have you studied this DFD in WOT subject? Okay, but that is one kind of DFD only. I mean to say that if you guys have studied DFD, then the context diagram will be there. Anyways, so this is one example of RMS calculating software. So here in this example, you can say that software, there is one software system called RMS, which is calculating software that would read three integer numbers from the user in some specific range of negative 1000 to positive 1000, and then it would determine the root mean square, that is nothing but the RMS of the three input numbers. Okay, and that is going to display it. So for that particular system who is going to read some three numbers from the user, and then it is going to give you the output of that particular RMS, calculating the RMS, so root mean square of that three numbers, you have to show that thing in level 0 diagram, the context diagram. Okay, So we can say that we can represent it using one process, that is the RMS calculator, and zero is representing that this is the is a level zero diagram, context diagram that would see in detail also, and how to do this numbering, and there is this entity user. Okay, and these are just the data flow things and data flow names that we are giving the data items from the user to this system. As I told you that we have to, whatever the name we have to give inside that particular circle, it should be such that it should justify whatever the system is doing. Okay, so at the level zero diagram, as it is for representing the overview of our system, the generalized way of our system, so we can have the name RMS calculator, and here it is from the user we are having the data items, we are giving as that data items as input to our RMS calculator, and from RMS calculator we are processing something, that detailed processing version we are going to have in next level of data flow diagram. And here we are just indicating that some RMS, that is the root mean square of that three numbers, whatever the data items we receive from the user, that we are giving as output back to the user. That is nothing but, in our case, it is the external entity. So to develop the data flow model of any system, first we have to model the abstract representation of any system. Okay, we have some kind of overview. We have to represent some kind of overview of that system, that what that system is doing, and that we can represent in abstract form in this context diagram, that is the level zero diagram. Whatever the problem is that about this system, that we can represent in an abstract form in this level zero diagram. And the most abstract representation of the problem is nothing but this context diagram. So after developing this level zero diagram, we can develop all those higher level DFDs, like level 1, level 2. So starting with this level 1 diagram, the level 1 gives the overview of our full system, and it identifies the major processes and data flows between them. So as I told you earlier that the level 1, the high level DFDs are nothing but just to represent the functionalities of our system in detail. Okay, so to develop the level 1 DFD, we have to first examine the high level functional requirements, and that too we can identify from the software requirement specification document itself, because we know that in software requirement specification document we have detailed functionality about all the functional requirement, also all the non-functional requirements also, like non-functional requirements can be reliability, maintainability. Okay, and functional requirements, whatever your system is going to perform, whatever the functionality that your system is going to perform. So all those things are depicted in that particular software requirement specification document. So to develop that particular level 1 diagram, we have to first of all identify all those high level functional requirements, and if we have to make sure that if there are like more than 7 processes. Okay, because here it is only one process, but as we go further we are having number of processes. So if our we should have to maintain the number of processes, there should not be more than 7 processes. Okay, that means that if there are between 3 to 7 high level functional requirements, then this data can be represented as like processes. Okay, in our further level DFD diagrams, right? So we can then examine that input data to this functions, that processes, and whatever the data that we can have as output from that processes, from that functions. Okay, so basically we have to provide all those functional requirements. We have to represent all those functional requirements which we have identified from that SRS document. We have to represent it using the process symbol in data flow diagram, but we have to make sure that it should not be greater than the 7, and that if it is increasing, the number is increasing more than 7, then that is also we can stop, and we have the solution for that also, and that will see that how we can merge them. Okay, so that is the thing, that we can examine the input data, we can examine the output data from that process, from that function, and we can represent them appropriately in that level 1 diagram. And as I told you that if there are many number of requirements, okay, then you can say that some of those related requirements, okay, we can combine those and represent them in the form of one process, one single process in the level 1 diagram. Okay, so in SRS document, if there are more number of requirements, you can just club the related requirements and you can just represent them as one single process, like 2 3 requirements. We can combine them, giving some just justified specific name to that process, and we can have that in level 1 DFT. So if a system has in case less than 3 functional requirements, then some of them need to be split into their sub functions, so that we have roughly about 5 to 7 processes in the diagram, right? So the thing is that it should not be too less. The processes, whatever we have in the level 1 diagram, it should not be level 1 or level 2, it should not be that less number. Okay, when it is less than 3, we can just split the whatever the function is there, we can split into the number of sub functions. We can decide the sub goals, and then we can have them as a process in our data flow diagram. So each process in that DFD is representing nothing but one kind of function that is performed by the system, and that process are decomposed in sub functions or sub goals at uh, time, if it is just decomposed into sub functions if it is of too less number of requirements from whatever we identify from that SRS document. Okay, so that decomposition is a decomposition of a process is also known as, you can say, factoring. Okay, factoring of a process, because we are just dividing them into factors, doing that particular functionality or dividing that particular process into some factors. We are just going to decompose it, and each process at any level, at uh, any level of DFT, data flow diagram, is usually decomposed at anything, you can say, between 3 to 7 process, because as I told you, there are too few processes at any level, make that level not worthy. Okay, so if your process is decomposed to just one process or two process, then this decomposition becomes redundant. And also, if there are too many processes, like more than 7 processes at any of your DFD, then also it would make your DFD model very hard, very complex, okay, to understand. Because the ultimately the aim is to represent your system graphically, pictorially, so that you can have better idea of your system, you can understand it thoroughly. So it should not be like too simple, or it should not be that much complex when you go further in levels of your DFT. So this decomposition of a process should be carried on until a level is reached at which your function of the process can be described, basically. Okay. And the same way at level 2, what we are going to do is we are just expanding whatever the process we have at level 1. We are just describing in whatever the process we represent in level 1, we are just going to represent it more detailed form in level 2 diagram. As I told you that as soon as we go further in levels, the detailing part of a system will increase. Okay. Now there is one another thing, as I told you, that why we give here the 0. Okay, that is one kind of numbering process. Okay, so the process at level 0 diagram or the context diagram is usually assigned the number 0, right, to indicate that it is of level 0 diagram. And whatever the processes that are at level 1 are numbered, you can say point 0.1, point 0.2, point 0.3, etc., and so on. So when in general, when a process numbered x, say for example x is decomposed, right, decomposed means it is we are decomposing into subfunctionality, so its children process are numbered x.1, x.2, x.3, and so on. Okay, so you can say that in this numbering scheme, in this numbering fashion, by looking at the number of a process, we can unambiguously determine its label. Okay, its ancestors or its successors. Okay, so that is why we have to use this numbering thing, so we can have the idea about the label, its ancestors, its successors, whatever the process. Okay, because in level 0 diagram we are having we can represent it in we can represent it like 0 by indicating the 0, and at further levels we can just represent it by 0.1, 0.2, and that is the thing that if say for example if we have 3 processes p1, p2, p3, uh, uh, that is one process P in our level 0 diagram, and then for the P1, P2, P3 in the next level, then we can label them as point 0.1, point 0.2, point 0.3. Okay. Again, if my process P1 or say for example P3 is again going to split into number of processes, then we can say like P31, that are those are the children of that P3 process. Okay, so P31, P32, P33. So how that we know in our mind, but how can we label that those things when we are actually representing them as a diagram? So we can label them as point 3.1, point 3.2, point 3.3 respectively, and so on. Okay, so it is the numbering of process level is going on like 0 at the level 0, then point 0.1, point 0.2, and so on. That is x.1, x.2, like that way in level 1. and after that, whatever the process we are going to split, decompose, that we can have like point x point 1, like that way. Okay, are you getting this? Yes. Did you understand this number, how to do numbering of process? Okay. So along with this, we have to balance our DFD, that is the data that flow into the process and the data that flow out of the process. We need to match that when any process is going to split, when any process is going to decompose at further levels, and that is nothing but one kind of balancing our DFD, one kind of balancing our DFD in terms of maintaining that data which is flowing inside the process and that is flowing out of that process, that should be matched. Okay, okay, so we'll see the examples in the next lecture. We'll stop here.